Greetings, folks, and welcome to the Electromaker podcast. This is your roundup of all things maker and embedded and lovely. We are back after quite a long gap. Since I got back from New Zealand at the start of the year, a lot of things have been changing behind the scenes, both at Electromaker and in my own life, so there was a bit of a gap. But we have a new series on the YouTube channel, which you may not be aware of, called Behind the Tech, which is a dive into various different subjects. And instead of being completely off the cuff like the Electromaker Show is, it's much more structured and answers questions that you as a hobbyist or someone who works in the industry or someone who wants to launch their own product might want answered. But the Electromaker Show is back in its original format as well, and today we're looking at a nice variety of things. The Bela Gem is a new music and sound creation tool from the Bela team, and it's just everything that the Bela and Bela Mini were and more. And I make no apologies for the fact that I'm such a massive fan of what the Bela project do. And we talk about it and the funding campaign in this episode, along with the new Arduino Nano R4, which brings that 32-bit Renesas chip on the Uno R4 with the 5-volt tolerance to the Nano form factor. We also go over Nordic's Wi-Fi 6 offerings at the minute, because since we initially covered the NRF 7002, they have expanded that into a few different directions, which are quite interesting. With that and one other funding campaign, which escapes my memory right now because I'm recording this introduction quite a while after I recorded the show, let's get on with it. But before we do, if you do like the show, please do give us a nice rating on your podcast app of choice, whatever that may be. If you're not already subscribed to the YouTube channel, please do head over there. And Electromaker.io is our online community hub, and it's where our blog is, but it's also where our shop is. And that is what we use to support the media that we make, like this. There are no apps in our podcasts. No apps? There are no adverts in our podcasts, at least not ones that we put in there. There's also no adverts on our YouTube. We tried to steer clear of doing anything like that thus far to see if it's possible to fund this without it. So if you are looking to buy anything, whether it's a gift for someone else or something for yourself, please do check Electromaker.io. It is a way that I would prefer to fund this show rather than having to reach out for advertisers at this stage at least. So with all of that said, let's get on with this week's show. In one of the last shows I recorded while we were still traveling at the start of this year, I talked about the PocketBeagle 2. Now, this is, of course, the follow-up to the PocketBeagle, which is the miniature version of the BeagleBone Black, a tiny Linux computer, which has some similarities to the Raspberry Pi. That's always the comparison that's drawn. But there's a few other things to it that made it really quite compelling. From a developer's perspective, there's some real-time processing units in it that could be really useful. But for me, the main thing that I really came to love BeagleBone for is the fact that it became the platform that Bela was built on. Now, if you're not familiar with Bela, it is a fully integrated music creation with code or pure data visual coding platform. It is essentially a piece of hardware that you can plug audio into or out of, and then you do what you want with it using code. But it has its own built-in IDE, and it also has a university-level course teaching you how to do real-time synthesis and audio processing from a university lecturer, along with too many other things for me to really get into at this point. But as soon as there was a PocketBeagle 2 coming out, my first thought was, does that mean we're going to get a Bela Mini 2? And the answer is yes. But it's not called Bela Mini 2, it's called Gem. So even though the funding campaign started and finished while I was off the air, unfortunately, I think this is still the best place to learn what this project is all about. So the Bela Gem Stereo and Multi, stereo because 2 inputs, 2 outputs with audio, multi because you get 10 inputs and 10 outputs, each independent from each other, are small Linux-based computers with high-quality audio hardware on the top of the cape, along with a few other things. And the software inside it is incredible. From the ground up, from the kernel level upwards, it is a fully real-time system designed to make audio the priority. So if you're doing some sensor work, if you're doing 1,000,001 different things, the idea is that your audio is always at a priority where you will not get audio cutouts, and it does all of the real-time scheduling in order to allow you to use all of the features of the hardware development side of the board. One of the big main things about Bela is that you can add almost any kind of input to or output to your device. You don't just have to have knobs and switches. You can have any kind of add-on that you could imagine, like an accelerometer or some kind of temperature sensor, and that could change the output sound. And that outputted sound could be literally anything. As I said before, there's a university level course that Bela has for free on the YouTube channel. We'll get into it in a minute, which teaches you how to code synthesizers from scratch, how to make audio effects from scratch. And if you don't want to do it in C++ code, it also supports Pure Data, which is a visual audio programming language. It allows you to do some visual stuff as well. It's a visual audio and visual programming language, I guess. And Super Collider as well, which is the backbone of a very popular live coding platform, Tidal Cycles. I almost forgot the name of it, and I would never have forgotten myself. So I waffled quite a lot in the intro there because I'm very enthusiastic. But let's talk about some specs for a second. What I'm not going to do is go over the specs of the PocketBeagle 2. They are here. They'll be linked in the description if you're interested. It's a very capable little single board computer. The new version is great. But the reason I'm not going over that is because even though it is the basis of what Bela are doing here with the Gem, from the very start, the Bela project has built their operating system and everything that they do around this real-time kernel that allows audio to work pretty much uninterrupted and with incredibly low latency, which we'll get onto in just a moment, and use their in-browser IDE and their own APIs and libraries in order to work with it, which again, we'll come on to more in just a moment. So from a hardware perspective, Bela is essentially just a cape for the PocketBeagle, but the amount of work they've done under the hood means you're not just buying a cape, you're buying a cape, an entire operating system, and years of research and years of refining and years of trying to make something that works equally well for makers and for engineers in the field as well who need audio. They need it now, they need it to be trusted, and they need it with low latency. Again, this is kind of Bela in a really sweet spot, in my opinion, in that regard. So the stereo cape has two audio input channels up to 24-bit at 96 kilohertz, which is more than anyone should ever need. Two output channels up to 24-bit 96 kilohertz once again. It also has 8 analog inputs, which are 16-bit. Now, these are more your using your ADSR kind of stuff. They're 16 bits, so presumably you could use them for some kind of audio level control. Like if you were making some kind of synthesizer, you could use that for control voltage more than likely because it is a high enough bit rate. But what we're really talking about here is analog inputs that can be used for a variety of reasons. That's your knobs, that's your dial, that's your nice little touch maneuvers. 16 digital GPIOs as well with 3.3 volt logic, USB Type-C and USB Type-A. There's one on the top here and one underneath. Can you see my mouse? You can. Underneath here is the USB Type-C. On top is the USB Type-A, which is incredibly handy because that means you can just plug a MIDI keyboard directly into Bela. And again, one of the things that they show in there, now I guess now's the time to show you. This is a full 22 episode series of learning to do real-time audio programming in C++ using Bela. This one's based on the BeagleBone Black version or the PocketBeagle version, so the full-size Bela or the Bela Mini. It doesn't matter. It's all still absolutely relevant, and it is my go-to thing. When someone says, how do I learn about this stuff? I say, here. Go here first. It is incredible. These are sessions put together by, as I have said many times in the past, a fully fledged university lecturer, one of the people involved in the Bela project when it was still a university project way back in the day. And this is genuine lecture slides that you would learn at a university level of learning how to do this kind of DSP. It is an incredible resource. And yeah, lost my train of thought ever so slightly. One of the things they teach you is how to use a MIDI controller specifically with the Bela straight in the USB-A port. And the other very nice to have thing we have here is the quick connector. There's now an I2C quick connector dedicated, plug in and go. Any of you who've worked with the quick system before know just how wonderful it is. I will not lie that I was sort of resistant at first. Like, why would I get this whole specific connector system to start working with I2C devices? As soon as I got my first quick connector converter and then a bunch of quick modules, I was like, why have I ever been breadboarding this stuff? This is so much better. So, on to the Bela Gem Multi. This is the same as before, but with 10 inputs and 10 outputs. And just saying that alone is somewhat mind-blowing because this tiny little device can quite happily handle up to 10 channels of audio. Now, you could use this for some kind of crazy spatialized audio. Let's say you weren't actually using any of the inputs. You were just generating your own synthesized tone inside the Bela. If you were to, say, make 10 different small variations to that tone, you could send one channel with a little bit of delay. You could put a little bit of phasing on one of the other channels, for example. Maybe you just cut out all of the high frequencies of one of the channels and all of the low frequencies of the other. Just give them pass filters and then send them out through different channels to different speakers. You could have a fully spatialized audio version of one signal coming from all parts of a room. Or, alternatively, you could plug 10 things in, affect them however way you want, and have them come out in 10 different speakers, combine them, do whatever you want with them. from a maker and performative perspective, that's what immediately grabs me because that's my wheelhouse, right? But from an industrial perspective, if you're someone who needs a lot of audio inputs and outputs and you just need to do a small amount of processing on them, some kind of validation, or maybe just some kind of making sure that whatever signal goes in isn't going to peak and destroy the speakers coming out of the other side, or there's a million and one reasons why you might want something like this. You could use one of these conceivably to run audio to multiple different sort of kiosk application points, for example. Again, this is trusted, real-time, super low latency, and years of research going into making sure that this thing works. Because if you really want, in an industrial perspective, for something to work flawlessly, yeah, use the thing that artists are using, because especially musicians, they're really, really picky about things sounding good all the time. Pops, cracks, anything going wrong is just death of that art. So yeah, there's a good reason why this is something that you might want to consider if you're an embedded engineer as well. Now, right here in the middle, I'm going to jump ahead a little bit and talk about the cost of both the Gem and the Gem Multi before we talk about a few of the other nice little things that I've touched upon before. The Gem Stereo costs $75, while the Multi costs $175. You will also need to buy a $28 PocketBeagle 2 on top. Now, I'm going to try not to soapbox too much in this moment, but I have been known on the show in the past to talk about the cost of things and this worrying trend people have of saying, oh my God, that costs so much. Why wouldn't you just get an ESP32 development board with some kind of audio stuff built in? And they exist. They exist on this very platform. And by all means, you could absolutely go and do that. But the other thing people say is like, why would I ever buy an accessory that costs more than the computer it runs on? You can absolutely find much, much cheaper audio interfaces for the Beagle board computer or any Linux single board computer. The point here with Bela is not just the fact that they have put a lot of care and attention into the hardware to make sure it is up to spec to please, as I mentioned before, musicians who are very hard to please. This is years and years of research. This is an operating system built pretty much from scratch. The operating system isn't 100% custom as far as I understand, but the operating system that they are using, which I believe is called ZenMI, or it was, if any of this information is wrong, Bela staff, if you see this, please correct me in the comments. That operating system does not hold your hand. You have to build it from scratch. It is essentially like building your own real-time operating system with building blocks that they give you. And that is what they started doing many, many years ago and have been refining it ever since. We're about to move on to the fact that they have a fully integrated browser IDE. And it isn't just the plain IDE that you get when you plug a BeagleBoard into the computer either. That IDE is very powerful, don't get me wrong. But as you're about to see, Bela have added audio-specific tools to it. There's a lot going on here. So the $75 that you're paying for the Bela Gem Stereo, you're not paying $75 for a piece of hardware that adds audio to a computer. You're paying for an entire cloud of years of experience and education and people who are really trying to make this thing work in a wonderful way. Okay, moving on. I hope my soapbox isn't too soapy. Things should cost money sometimes. So, moving on to the in-browser IDE, as I mentioned before. The browser IDE of Bela went way beyond most other sort of browser-based IDEs that I've come across before, in that it does have a code IDE in there. You write your code, it works, it will tell you if there are errors, it does all of that in the browser. You can build and run in the browser, you have a console in the browser. You have the Project Explorer as well, which again, that might not be too out of people's wheelhouses because then you can just open projects in the browser as it is. But here's where it gets kind of special. If you click down here, one of these buttons is a fully functional oscilloscope right there in the browser on the audio product that you're working with. Now, if you've ever worked with anything audio before, you will know how insanely powerful that is. To be able to see the signals that are coming out internally and work out exactly what is going on with your code. This is just an incredible debugging tool, and it's part of the tools that they use in terms of teaching as well, because when you're learning how to do all of this kind of stuff, as I've left this thing playing in the background, you can create waves out of code and then see what those waves look like in the oscilloscope in the browser. It is an incredible learning tool. It is also an incredible debugging tool. Also, in the browser, if you press a certain button, a blank screen will come up. And that is because you maybe haven't actually set up a UI yet, but you absolutely can. The truly wonderful p5.js, that is the web version of processing, which is a wonderful tool for artists to create visualizations and various other things using code. Again, a very maker-focused platform that is so easy to use, it's been adopted by all kinds of people. P5 runs natively in the browser and integrates into the Bela project. So if you were wanting to make a synthesizer or something with some hardware controls, but you just want to do the software side of things, you start your project, you can make a website essentially inside the Bela board itself, and then use your mouse or your keyboard or anything like that to test things with a virtual UI before you even start adding things like sensors and buttons and dials and anything else you want to use. It is an incredibly powerful addition to any IDE, in my opinion, the idea that you can add an interface to your embedded project without having to actually get the buttons and dials out to begin with, and I'm very glad that it is here. But I'm only talking about things that were in the original Bela IDE that has been around for a while. This has now been updated, and there's now integrated monitoring and debugging for your project as well. The visualization has been enhanced, so the oscilloscope is now an advanced oscilloscope. I haven't had the chance to actually look at this myself, but the oscilloscope was great already. I don't really know what the enhancements are going to be. And as I mentioned before, it supports C++, Pure Data, Super Collider. I forgot to mention Faust and Max RNBO, I don't even know, and C-Sound, which is, of course, a wonderful library. So it allows you to work exactly how you want to work, essentially. And Pure Data is something that I think more people should know about, because even if you understand the very basics of programming knowledge, or not even knowledge, sorry, like flow, if you understand if statements, for example, if you understand the very basics of that but haven't really settled on a language yet, you can make some truly beautiful stuff with Pure Data, and it's completely free to get started with. And again, once you have learned how to make some kind of a synthesizer, some kind of wobbly wibbly noise, if you want it to be in a box of your own, that when you put your hand down and closer to it, it goes woo, you can do that by just making your Pure Data patch on your computer, on your laptop, in a cafe, anywhere you want, and then integrating that Pure Data patch into the Bela IDE, putting it onto your board, and there you go. You have a standalone hardware synthesizer without having to write a single line of code. So as you may have realized by this section, I'm deeply biased in favor of the Bela project. And this isn't a sponsored section. This is just because this project typifies exactly what I love about embedded engineering and creating your own synthesizers and crazy devices. It's something that I've loved for many, many years. And as I mentioned earlier in the section, perhaps, I've been working on my own audio development platform from scratch for a while now, which only makes me appreciate even more the steps that Bela has taken over the years to make this thing as wonderful as it is. But I just want to end up this section literally just by quoting one of the paragraphs of the crowd supply page that should just really give you an idea about what Bela is about. Bela Gem is designed from the ground up for projects where timing and feedback matter. With hard real-time performance and latency of 1 millisecond, it excels in use cases where responsiveness is critical: digital musical instruments, audio effects, haptics, assistive devices, and more. Add in high-resolution analog inputs and a generous spread of digital GPIO pins, you've got a system ready to be the bridge between the digital and physical world. And that's it, really. If you're looking for an audio development platform that gives you a lot without having to worry about the underside of it, without having to worry about all of the timing critical stuff on the back end, that you can just plug into a situation and program in a variety of ways, Bela has been one of my favorite things for many years, with good reason, and I implore you to check it out. If you are interested in finding out more about it, the funding website things page, that's not what it's called. The crowd supply page is still up, and you can make a purchase from there. This crowd supply project, like all crowd supply projects, runs after the fact. So even though they have reached their funding goal, that just means that the page will stay open. You can still put in an order, and that order will be placed into the backlog and sent out in order of people that actually supported the project. And of course, I will be updating you when that starts to happen. Sticking with funding website things, we're going to look at MathPad. Now, this is a wonderful macro pad for mathematicians. And it does exactly what it looks like it would do. It gives you access to over 120 characters most commonly used in mathematics, if you're using LaTeX as software for doing mathematics or whatever you're using. And as you're seeing on the screen now, it has the Greek alphabet, calculus symbols, accents, set theory, logic, and various different number systems. And it is plug and play regardless of your operating system. This works on Windows, it works on Mac OS, it works on Linux. This is, once again, another project that was mentioned to us while I was off the air. So we're getting to this after the fact. But as you're seeing, they were asking for a simple $1 goal in order to get this thing up and running. Essentially just trying to get eyes on it to see if people would want to buy it. And they've raised up to, over $10,500. So this is something that's going to be going into production. As with the Bela I just talked about, you can still purchase one by clicking the purchasing options, which I will get onto in just a moment. So the board itself, as you can see, is a small macro pad with 3 different shift keys, I suppose you could call them, very nicely color-coded so you can see exactly what to use. I imagine that if you had one of these and used it for a couple of days extensively, you wouldn't need to look at it anymore. You just know exactly which combinations you would need in order to type mathematical symbols very quickly. Now, I will hold my hands up and say this is something that, to me, has never really been too much of an issue because I am allergic to mathematical symbols. One of the main reasons I love digital signal processing so much is that I can take those mathematical symbols and just put them into just straight up code. Just give me normal letters and if statements and a compiler that will complain if I get something wrong, or not complain and give me completely the wrong answer because I don't understand the maths. But that's where I am. But I can absolutely understand the utility of this for people that have to write mathematical notation all day, every day as part of their studies or part of their employment. So alongside these set symbols for the device, there's also different output types as well. So whether you're working in plain text or using LaTeX, Office equation editor symbols, or LibreOffice equation editor codes, you can do that just by basically another key combination will change between them, which is going to be very useful for people working with a variety of different tools, I would imagine. Now, if you are interested in finding out more about the technical side of this, you can look under the support and documentation tab. It can take you straight to the GitHub and you can look at how it's all put together if that interests you. This is an RP2040 based design, by the way, using Raspberry Pi's wonderful little microcontroller. And there's a few other things like the Getting Started guide there as well. So if you are wanting to support this and get your hands on one yourself, you can get the MathPad for $140. Remember that little rant I went on in the last thing about how small creators creating things themselves are not just selling you the parts, they're selling you the work they've put into them. This is a reasonable amount to ask for, especially if you do maths all day, every day. This is, yeah, $140, and of course you can get accessories like the cables and things like that. And despite the fact that this project is finished, you can buy one here from the view purchasing options thing, which will take you down exactly to where we were just looking. Links to this and of course the Bela Gem and anything else I talk about in this show will be in the description of this video. If you are enjoying this show, please consider subscribing to our YouTube channel, liking this video, leaving a comment, all the usual YouTube things. And we don't run any ads on YouTube at all, and we'd like to keep it that way. We don't have any ads in any part of our process at the minute with our media, apart from the occasional sponsored section. And the best way that you could support us financially if you wanted to, rather than having to sit through ads, is by going to electromaker.io and checking out the vast array of things we have in our shop. Because we sell things that pertain to everything I talk about on the show, whether you're a hobbyist just starting out, or maybe you want to buy a gift for someone who you want to give that first spark of interest into the industry, the same way that we all got at some point. Or maybe you're at the other end of the scale and you need to get something to develop on, or you need to get 10,000 of something for your team. Our shopfront is designed to be able to deal with all of that. If you are up at that need 10,000 something, you might want to just ring them rather than look through the shopfront. But the fact is, we're able to cover all of that. And the reason that we are wanting to do it that way is because, again, I like the idea of being able to do this without having to shoehorn ads in or know that you're sitting watching through YouTube mid-roll ads in a video or something like that. So yes, if you are enjoying it, please do the YouTube clicky things. And if you're looking for the next thing to buy for your next project, do head to electromaker.io. Now, a few times on the show, we have talked about Nordic's NRF 700X series. And I'm saying 700X because back then it was just the 7002, a Wi-Fi 6 IC from Nordic. It was quite exciting news at the time because Nordic, a company well known for their Bluetooth low energy offerings over the years, had finally stepped into Wi-Fi. And they made it clear at the time it's because Wi-Fi is now ready to take that place. And Wi-Fi 6 allows you to do a variety of things with an incredibly low power draw that you couldn't do in the past. Things like using Wi-Fi for location, for example, something that just was not even an option for devices with the power requirements that you would usually find them in. And of course, what with this being Nordic, it works perfectly with the rest of their stack. So you could have a device that has a GPS and uses cellular for outside, or works with Bluetooth inside, or Wi-Fi 6, or any combination of those things working together nicely. But we're going to revisit it now because the NRF 7 series has evolved to an extent. And there's various ways that you can work with it, and I thought it was time to check back in and take a look. So way back when at a trade show, it may have been Electronica, it may have been Embedded World, I remember being showed the pre-release of the NRF 7002, which is essentially the development board for working with the 7002 IC. The board itself is super powerful. It comes with the NRF 5340, which is still the flagship chip from Nordic now, although the NRF 54 series is about to change all that. That's a story for another day. But yeah, the NRF5340 is their flagship Bluetooth Low Energy chip. It's not going anywhere soon, but it's also being used here as the host for working with the 7002. Now, it says here, this is the development kit for the 7002 and NRF 7001. We'll go through the differences between those in just a moment. But the chip itself, as it says here, it's a Wi-Fi 6 companion IC. So it provides, well, Wi-Fi connectivity, as you might imagining, but also Wi-Fi based locationing using SSID sniffing or local Wi-Fi hubs. SSID sniffing is a really interesting concept, and the tech behind it is something that maybe we'll look into on another day. But essentially, the idea is that even unknown Wi-Fi hubs are able to connect in a way that gives enough information without releasing any private data as such. It's a sub-network that exists in Wi-Fi that allows you to use signal strength as a way of discovering position, which is a really interesting thing. So it's designed to be used along the existing NRF 52 and 53 series Bluetooth system on chips, soon 54, along with the NRF 91 series cellular IoT systems in package. As I was just mentioning, this is Nordic stuff. It all works happily with each other. So if you just needed a cellular device that uses Wi-Fi for locationing when it's in a place where maybe it wouldn't get a cellular signal, or a cellular device that needs to dump a large amount of data every now and again, so when it's in a position like that, when it can actually do it over Wi-Fi rather than using a huge amount of cellular data, that might be a position where you wanted to use it. I wanted to start by talking about the NRF 7002DK just because this is by far the easiest way to get started with this tech. Nordic development kits are incredibly fully featured. They pretty much open up every aspect to it you might want to work with. For example, the power management tools, we'll be talking another day about Nordic's PMIC, the power management integrated circuits, which put all of your power management into one little chip. That's on the board. If you want to profile the power, there's pins for doing that. If you want to use add-on shields, for example, there's Arduino compatible shields on the board, along with pretty much every other input and output that you would want. The general rundown, as I've mentioned, the NRF 7002 just does everything that Wi-Fi 6 brings to the table and does it with the expected Nordic style. Very, very low power, and using that Nordic NRF Connect SDK backend, which is based on the Zephyr real-time operating system. And in fact, if you really want to get started with one of these, a really good way of doing it is to head to Goliath. Goliath are an online IoT platform. They run some fantastic teaching tools specifically about the NRF 7002DK, and Nordic's own fundamentals course for the NRF Connect SDK is a brilliant introduction to Nordic's way of working and the Zephyr OS in general. Which, by the way, if you just go to the resources tab and click the Nordic Developer Academy, that's where you find it. There's a lot of really good stuff in there. And this IC is available in a few different form factors as well. They have the Arduino Shield compatible Shield, the Arduino Pin compatible Shield version of the NRF 7002, although do bear in mind that this is a 3.3 volt tolerant shield. You don't want to stick this into an Arduino Uno, you'll let out the magic smoke. But there is the EK version of it. There is also the expansion board version of it, which is designed to fit perfectly into various things. So for example, the Thingy 53 is their Bluetooth Low Energy prototyping kit, the little blue box that can do a bunch of stuff, including onboard AI and all kinds of stuff we've showed in the past on the show. This will plug into it and add Wi-Fi 6 directly to it. Or you could just get a Thingy 93X, Thingy 91X, these numbers are getting to me, a Thingy 91X, which is the newest version of their cellular IoT powerhouse for prototyping, which just has Wi-Fi 6 built in. But the NRF 7002 is not the be-all, end-all in this situation. The thing that's wonderful about it is that you can, of course, just use the elements of it that you want, but you don't necessarily need all of those features in your design. So as a way of saving cost when it comes to your designs, especially if you're coming up with a completely custom-built PCB and you're very conscious of your bill of materials cost, is things like the NRF 7001. Now, this is, as you can see from the comparison chart, almost exactly the same chip as the NRF 7002. It just comes only in a QFN package, and it's missing 5 gigahertz connectivity. That's it. That's the only difference you're going to find here. And the great thing about it is, of course, you can still use the NRF 7002 in order to do all of your development stuff when you have a development kit, and then integrate this into your design later. There are also various modules available. We'll be looking at some of those in a moment as well. And much like we have the NRF 7001, which allows you to laser focus in on what you want, if you only need Wi-Fi locationing, that's where the NRF 7000 comes in. The NRF 7000, I suppose you would call it. And again, this is a laser-focused approach to the idea of the chip. So the NRF7002 is the all bells and whistles, does everything chip. If you just need something that can use 2.4 and 5 gigahertz connectivity for Wi-Fi locationing, you're going to want the NRF7000. And each one of these pages, each IC has its own page. And you can also head through to the third-party modules page. And this will show you various different companies that have taken this tech and put it into modules already. So if we start, for example, with this, which is from Ablutech, I believe this is the first one in the list. I just clicked here. Yeah, the PTR7002. This is a very familiarly shaped module that you could fit onto any PCB that will give you the full power of the NRF7002 and the antenna directly into your project. And that's fantastic. That gives you everything that you need. And again, you can use this as the full bells and whistles 7002. You could use just some of the features of it and have it so you could upgrade it in the future. And of course, there will be modules based on the other chips as well, the 7000, if you just need locationing. But similarly, if you want to get something that has a little bit more oomph to it, one of the FanStel modules here, once again, I don't know, I believe it's the WT02E40. C40, yeah, WT02C40C, and various other ones. These are quad radio NRF7002 and NRF5340 combined chips. These are designed to be your one-stop shop for any kind of connectivity that your IoT device may need, adding Wi-Fi 6 and Bluetooth Low Energy with the antenna in various form factors right in there too. So if you would like to know more about any of the things I've just talked about here, head to the Nordic website. For me personally, the NRF7002 became really interesting from a personal perspective after I saw Eli Hughes' amazing guitar active pickguard project. I talked about this project on the show. I actually have an interview with Eli on this channel about this project where I get way too enthusiastic. I will leave a link to that in the description. But in this particular use case, Eli has created a guitar that will take everything that you play from the guitar and it goes through a DSP system. And that DSP system basically will log absolutely everything that you play, using the Nordic part in this particular instance as a way of dumping all of that data off the device after the fact. Imagine a guitar that remembers absolutely everything you play and the settings you were using when you played it. It's an amazing idea. Anyway, yes, if you head to the Nordic website, nordicsemi.com, you can get more information on this. In a moment, we're going to move on to talk about the Arduino Nano R4, but before we do, this is a new show on the Electromaker YouTube channel. The eagle eye among you may have noticed I am hosting another show. Now, if you find the way I do the Electromaker Show to be somewhat abrasive with my fast talking and mumbling and losing track of things and just generally boiling to death in an attic in 35-degree heat in Berlin, I don't blame you. If you're looking for a show which features me but is a lot more focused, gets the information straight across, I'm even reading from a script, this will be the show for you. Behind the Tech is a show that goes into very specific questions about embedded engineering and looks into the kind of things you might want to use as your tools. The first one was what development board in general you might want to use for various different projects covering connectivity or robotics or whether you're doing smart home or whatever. That was the first video. This second one is even more focused specifically on shipping an IoT product using a single board computer. There's a lot of options out there. We look into what if you need x86? What if you need deep processing power with AI? And we talk about, of course, NVIDIA when it comes to AI. x86, we're talking about Latte Panda. But we're also talking about the kind of support you get across the board. If you're looking for a budget piece of hardware, Rockchip boards are incredible pieces of hardware for the money. But what kind of support are you going to get, A, in programming it in the SDK, and B, further down the line when you want to support customers with OTA updates and just deal with all of your cloud data? Raspberry Pi is way better in this regard because it's so supported by everybody. But then you go to the other end of the scale with things like Particle, which is a company I kind of thought of as a cloud-based solution. And I don't mean that in any kind of shade. Just more a case of Particle have spent 10 years supporting customers' pieces of hardware. They just happen to have their own hardware as well. And now their latest piece of hardware is actually very special in its own right. It's a 5G-enabled Linux-based single-board computer, but the innards is the same as you find in a smartphone. It uses the same Qualcomm chipsets as you find in smartphones, but with upstream Linux support. So yeah, we go through all of those different things that you might want to consider as an IoT designer who wants to support their product down the line. And it is done without all of the stuttering and speaking fast that I've been doing in this very section. So if that's the kind of show you're into, head to our YouTube channel and look for Behind the Tech. I mean, you'll see my face in the thumbnail. It's me again. Anyway, moving on to the Arduino Nano R4. This is our product of the week, and we have an ongoing giveaway for it that you can enter by heading to this video. Just a quick tip, if you're not familiar with this, I'll link the actual video underneath as well, but if you're in the blog post and you want to get to the comments of the video, just click on the title like this. It will open it up in a separate browser window. But as always, our in-house engineer, Robin, has a video giving you the rundown of the Nano R4. But in many respects, I'm sure a lot of you out there will understand just exactly what this is without having to think about it too much. The Arduino Uno R4 was the biggest revision we've seen of the classic Uno that kind of started it all, that we've seen in years. Even the revision 3 of the Arduino Uno still had the ATmega328P chip on it, which is a wonderful microcontroller and the first that many of us learned to program for sure. But in this particular instance, it was becoming a little outdated. There's so many chips that completely outstripped it. And with the rise of the ESP32, it was high time for an update. But what Arduino did was super clever. They waited until there was a chip on the market that fitted the exact demands of what the Arduino Uno might want to do, but retained its 5-volt tolerance. That means that every single Arduino project design, the hardware design, every single Arduino starter kit over the years, all of that kind of stuff is compatible with the new hardware natively without having to worry about people putting 5-volt logic into 3.3-volt logic pins and blowing up their brand new development board before even learning why they made a mistake. Now, if you'd like to know the full details of the technical side of this, Robin has you covered once again. Link in the description. Robin's videos are always very dense with all of the information that you need, also with Robin's particular sense of humor and downright obsession with USB Type-C connectivity, which I share to a small extent, but he's high up in the USB-C church. But yes, he talks about the RA4 M1 chip and the various advantages about it. And as I've mentioned, you can win one as well if you would like to. Now, I have a weirdly sort of personal relationship with the Nano and the Arduino Uno, and I'm sure I'm not alone in this. So the fact that the Arduino Uno and Nano had so much parity and had the same chip meant that almost every single beginner project I had used an Uno or a Nano, and the hardware side of things could be exactly the same. One of the first things I ever turned into an actual project was just a very simple binary clock. And we've all made them before. And mine didn't have any way of setting the clock. You set it in code. And then I think the way I set it is I set it so that it would start at 12 o'clock. And then I uploaded the code. And then I pulled it out the USB. And then I plugged the battery in when it was 12 o'clock. And then just let it run. And of course it drifted. It doesn't matter. The idea is that I remember the joy of taking an Uno project on the breadboard, putting it onto my first bit of proto board, putting a Nano in there and having this nice little enclosed thing that just worked. And all of those old projects, all of those old ideas, anything that's been written for the entire history of the Arduino Uno and the original Nano will now work once again with these new 32-bit microcontrollers using exactly the same language, because the Arduino IDE has retained its language. You want to write to a pin, you use digital write. You want to read from a pin, you use analog read or digital read, depending on what you want to read it. Arduino is, of course, well known as being the fantastic beginner way of getting into things. And while there are a lot of different ways you can do this these days, the Nano, and especially that original idea of the Nano, is something that's burnt into my mind. If you are interested in finding out more, do head to our Product of the Week blog post and video, which will be linked in the description below. And by the time this video goes out, there should still be time to enter the giveaway. But every single Product of the Week that we put up, if you check our YouTube channel, has a giveaway in the comments section there. So while the Electromaker Show isn't as frequent as it used to be, there are other ways to find out about our contests, like heading to the YouTube channel or following us on our social media accounts, where we'll be posting every time we have a new Product of the Week or giveaway, so you can see everything that is happening on the Electromaker channel. That was the show for this week. Thank you so much for joining me. Thank you for your continued support, especially in our absence. I'm very glad to be back doing this. The Electromaker podcast will be still coming out fairly regularly. It won't be as weekly or every 2 weeks or however much I managed to get it done in the past. Just because, as I said, there's been changes both in my life and in the way that Electromaker is doing things. But do check the YouTube channel regularly if you are someone who is interested in what we do. Because Robin is still frequently putting out his Product of the Week videos. I have my new series with Electromaker, Behind the Tech, and there's a few other things in the pipeline as well. But for now, as always, you can support us by going to electromaker.io and browsing our shop, or joining our community hub and sharing your projects with us. But that's it for this week. I look forward to chatting to you next time. Have a fun, safe, and creative week. Take care.